Okay, we're back with a couple of examples. So the first thing I'm going to do is we're going to look at the equation x cubed minus 3x squared plus 1, which is actually the graph that we have behind us, and we're going to look at how we can get this picture from just the equation. I can't point in opposite directions here. Okay, so here's my function. I don't know anything about it, okay? But I want to graph it. So what did we say before? We said that where my function is increasing, my derivative is positive, and where my function's decreasing, my derivative is negative. So the first thing I have to do, take the derivative. This is nice. It's a polynomial. Nice derivative. Okay, so 3x squared minus 6x. Now to figure out where my derivative is positive and where my derivative is negative, I actually have to find out where my derivative is equal to 0. So I need to factor. So step 1 here, next step, I'm going to factor f prime. Okay, what does that give me? Well, I can factor a 3 and an x. So I have 3x times x minus 2. That's how I factored it. Okay, so I want to know where it's positive, where it's negative. Make a number line. Put the zeros on the number line. So the zeros are 0, where 3x equals 0. Okay, these are my zeros. Oh, you guys can't see that. Just slide you over so you can. Okay, and I set x minus 2 equal to 0, so x equals 2. 0 and 2. All right, now remember how we do this? We just pick a number. Remember this from pre-calc. If I choose negative 1 gives me a negative here and a negative here. Negative times a negative is a positive. So my y values are positive. My derivative values are positive there. I choose a number between 0 and 2. Say 1. 3 times 1 is 3, that's positive. 1 minus 2 is negative 1, that's negative. So my derivative values are negative here. Notice I'm plugging them into the derivative. This is a sign chart for my derivative. And if I choose a number bigger than 2, say 3, 3 times 3 is 9, that's positive. 3 minus 2 is 1, that's positive. Positive times a positive is positive. So what does that tell me? This tells me about increase and decrease. Wherever the plus signs are, my derivative is positive, I have positive slopes, I'm increasing. So I know that my function increases from negative infinity to 0 and from 2 to infinity. Aha! Look over here. We're increasing for all those x values all the way to 0, and we're increasing. Starting right here at x equals 2, all the way for all of these x values. Remember, I'm describing the y values. So for these x values, all the ones over here, my function's increasing. All the x values after 2, my function's increasing, and I'm decreasing from 0 to 2. Okay? Here's something else interesting. If we look, my function increases, decreases. So we call 0 a local maximum. Okay, we're going to talk about that more later, but what does that mean? It means that it's got the highest y value around. It's not the highest anywhere, but it's the highest around. Kind of like in New England, Mount Washington is the highest mountain, but in the United States, it's not. Just locally, it's the highest. And positive 2 here, my function decreases, then increases, so we call 2 a local min. Again, the same idea. In its little area, it's got the lowest y value. Where we live, Bethel's the lowest point, not the lowest point in the US. It's a local minimum. It's a valley where we are. We're going to do one more example in my next video.